Hello and welcome to OER on a Boolean function simplification technique using Kmap method. This OER creation is a part of a STP on use of ICT in education for online and blended learning organized by IIT Bombay. This work is taken from a book called Digital Design by Maurice Mano, EBS co-publication, and way back in 2002. Simplification of Boolean function is very much important job. Why? Because it reduces the number of logic gate used to implement combinational logic. Smaller the number of gates, cost of the implementation will be less. So generally two methods for simplification of Boolean function is discussed. One is the algebraic method, which uses the identity and basic laws to simplify the Boolean expression, and another method is a graphical method whereby we create a Kmap map and then using unique properties of a Kmap map we simplify it. So Kmap or Kmap map method is very easy and straightforward. Kmap consists of several cells. Typically for n variable it has 2s to n cells. In every row and column, two adjacent cell, the rule is the two adjacent cells should differ in the value only one of the logic variable. The truth table typically of a Boolean function can be expressed as follows. So here this table shows the 4 variable Boolean function. It can be listed one of the way like this, whereby the combination of A, B, C, D, which can go from this 4 being a 4 variable to rest to 4. So 16 combination one can have from 0, 0, 0, 0 to 1, 1, 1, 1. And decimal equivalent numbers is shown here, 0, 1, 2, 3 to 15. So from 0 to 15 there are total 16 combinations, and against each combination the output is decided depending on the nature of a Boolean function. So whether if it is 1, then for this combination output is 1, for this combination output is 0, and likewise. So this variation in f that decides different Boolean functions. Now let us look at what is the sum of product form of a Boolean function. Now the same function which has been shown in a truth table form as follows can also represent in a sum of product form. As name shows, it is nothing but a summation of several product forms, and the product form, as we know and we had seen earlier, it is nothing but a mean term, which is nothing but a multiplication of each variable or complement of it. So this same function can be represented as a mean term summation. It is nothing but a summation of a mean term 0, 2, 3, 5, 6. You can appreciate more on this side. So 2 is 1, 0 is 1, 3 is 1, 5 is 1, 6 is 1, and likewise. So any Boolean function can be expressed in this sum of product form. And the 0 equivalent can also be put as a dash, b dash, c dash, and d dash, which is nothing but 0, 0, 0, 0, equivalent to the 0 mean term, and likewise 0, 0, 1, 0, which is equivalent to the 2 mean term 2, small m2, and likewise. So this every term on the right hand side is called a mean term. Now the issue is that it can be reduced, and so that we need a least number of logic gates. So either you use identities of logic Boolean functions, or you can use a Kmap method, which we are planning to do now. Typical the 4 variable Kmap is shown, and please notice that adjacent cell just differs by one variable change. So here one can see the CD, C doesn't vary, only D varies. If I look at this, so AB also, or AB does not vary, C does not vary, just D varies. Similarly for this two combination, AB doesn't vary, D does not vary, but C varies, and likewise. So This way, if we look at the binary equivalent number, it will goes like this: 0, 1, 2 here, and then 3. Then 4, 5, 6, and 7. Then 8 will come here, 9, 10, and 11. Then 12, 13, 14, and this is 15. 1, 1, 1, 1. So these way you have each number associated with each cell for a Kmap. And now the method is very simple. We are putting 1 for the Boolean function, as this Boolean function has values of 1 as an output for these mean terms. So we are listing exactly the same pattern here. And now the step 2, which combines adjacent ones into the group such that each group contains only ones. So in short, we are finding ones, and group size could be 2, could be 4, could be 8, could be 16. And naturally, group is not completely part of a larger group, otherwise the simplification will reduce to 1. Third step is to choose the minimum number of such largest size groups. So if I have if it is possible to make a group of 8 ones, then we should make it that 8 1. Otherwise, it should be 4 ones or 2 ones. So such a way, if we simplify and look at that, this there is a combination of 8 ones I can see here. And if I see the breadth and width, the column wise and row wise, so whichever variable varies, that one should not include. So here you look at B varies from 0 to 1 and 1 to 0. So we are not including across the length. So across the length, once again we check A, then A also varies. And across this length, 1, 1, which doesn't vary. So the answer representing value of this 8 cells is just a C. So there you can see here C is one of the answer. So such groups, if we formulate and then we add, it is nothing but the simplified solution of the Kmap. So to make it complete, let us look at, now important that first row and last row should be also called adjacent rows. Similarly, first column and last column is also adjacent. So you can see this one, this one, this one, and this one is also forming a group, which is a group of 4 ones. So for that, if we closely watch, C varies from 0 to 1, but D does not vary. So D dash is one of the literal which I should include. Then here 0, 0 does not change, so B dash is there. So B dash, D dash is the another combination. One has to put it as another logical OR function along with C. And but a rule is that one has to include all ones. So by including these 8 and these 2, we could cover on we could cover only few ones. Now this one is yet to cover, and that can be done by, because maximum possible group using this one is just 2. So this 2 can be represented as A dash B times D. So you can see the third term is A dash B times D. So this way one can simplify any Boolean expression which has been listed either in sum of product form as specified here, or it can be or it represented in form of the truth table. So such simplification of a combinational circuit is very important, and Kmap is very important method. Thank you very much for watching this video. Thank you.